Hi everyone, welcome to section 2 of Big Data Analytics using Apache Spark. Here we will talk about exploring the Spark module. At the end of this section, you will be able to work with the Spark shell. Also, you will explore the one-to-one relationship between Spark session and Spark's language API. Finally, you will be able to start writing Spark SQL applications. In this first video of section 2, you will see hands-on demo of Spark's interactive shell. Also, you will understand Spark as the big data processing framework as well as the architecture diagram of the Spark application. With the help of Spark's language APIs, you can write Spark applications using Java, Scala, Python, R as well as SQL. With the help of Spark's language APIs, you can write Spark applications using Java, Scala, Python, R as well as SQL. Let us see an example of creating a data frame based on the content of a JSON file. I am on my Mac terminal. Here I am already switched to the Spark directory. On the Spark folder, you can type bin/spark-shell, and if you press enter, you will enter into the Scala's interactive shell. Here we are creating a data frame from the content of a JSON file. In order to explore the content, we can type df.show. As you can see here, this displays the top 20 rows of the JSON content. In order to come out of the Scala shell, you have to type :Q. If you are a Python programmer, you can also type the same program in Python. To enter into the Python shell, instead of typing bin/spark shell, we have to type bin/pyspark. What you see here is a Python interactive shell. As you can see here, it is the same API spark.read.json. And in order to explore the content of the JSON, you can type df.show, which helps us to explore the top 20 rows of the data frame named df. In order to come out of the Python interactive shell, you have to type quit. If you are an R programmer, you can type the same program in the R interactive shell. To enter into the Spark R interactive shell, instead of typing bin/spark shell or bin/pyspark, you have to type bin/sparkr. Here is the equivalent code. Instead of spark.read.json, here we have read.json. Let's try this code. In order to see the content of this data frame df, you can also type head of df. To come out of the Spark R interactive shell, you type the same command quit, and it will pop up saying whether you want to save the workspace image. In our case, it's no, so I type n. As discussed in previous videos, Spark is a big data processing framework. In simple words, Spark coordinates as well as manages big data processing tasks on cluster of machines. Next, let's explore the architecture of a Spark application. In fact, it has two things. Firstly, a driver process which runs the main function. This is the heart of any Spark application. Moreover, it maintains all the application information throughout the life cycle of a Spark application. Secondly, it has set of executor processes. These executors perform all the tasks assigned by the driver process. On the other hand, in this course we use local mode instead of the cluster mode. Hence, both the driver as well as the executor processes run within a single laptop machine. In fact, in the start of an interactive local mode, a Spark session is implicitly created. Spark uses Cluster Manager to manage the cluster of machines which executes tasks. As discussed in section 1 video, you can use Spark's standalone Cluster Manager, Yarn, or Mesos. In other words, the Cluster Manager is responsible for allocating resources to finish the task submitted by the Spark application. Spark code runs on the cluster of these machines with the help of the Cluster Manager. However, we don't show these cluster machines on this figure.